Welcome to this video on securing Webster MQ channels on the ZOS platform. My name is Mark Womack and I work at Webster MQ Level 2 for IBM. We're going to discuss using SSL on the ZOS platform, and we'll describe how to use RACF as a certificate authority for MQ certificates. We'll demonstrate how to connect certificates to the keyring, show how to export certificates on ZOS to a data set so that you might be able to use that data set and its contents to move certificates to other platforms. In this way, this enables you to administer all your certificates on, say, Z, and move them to clients or servers that you might also want to be able to authenticate. And we'll discuss some common types of certificates often used to administer SSL. Okay, so now why would any business want to use SSL anyway? Well, many businesses use SSL to secure their MQ channels, and because it allows them to authenticate both servers and clients. It enables customers to encrypt sensitive information as it crosses through the network, and it protects data from tampering through non-repudiation. Non-repudiation provides proof of the origin so that you can avoid the so-called man-in-the-middle attack. So let's take a look at how we get from where we are now to there, where we actually have a keyring in place with certificates. The steps generally are to create the keyring, to generate a CA root certificate, and to connect the root certificate to the keyring. We'll be using a 7.1 queue manager. RTP9 is the name of that queue manager. The CHIN is RTP9 CHIN. And in order to discover the attributes of this queue manager, we'll issue in a moment a display queue manager all command to get an idea of its current settings. Before we begin that though, I wanted to show that in the job log for the CHIN there is always an IEF 695 message that will be issued, and this message contains the name of the user that will always be associated or assigned to that started CHIN task. In this case, on my system, that user is MQM task. And this is very important because whenever I issue any jobs that I'll be running today, I will have to specify that ID in my job to give RACF proper information about the authority that I have to issue these commands. Okay, so we'll issue the display queue manager all command and take a look at the attributes for SSL for this queue manager. Backing up to the beginning of that output for the display queue manager all command, you can see that I have an SSL keyring setting of secure.ring. So any certificates that I add to the RACF database or to the keyring associated with my queue manager have to go to this keyring. Also, I have an SSL task setting of 2. SSL tasks indicate just what resources I'm willing to assign for SSL calls that are received. Now the SSL key R value or SSL key ring value is a name that can be up to 256 characters long. The SSL tasks value, in this case chosen to be an integer of 2, determines the number of subtasks used to process SSL calls, and you have to have at least 2 of these in order to run SSL channels on ZOS. Now while you can code any value for this parameter between 0 and 9,999, it is recommended that this value never exceed 50, since this may lead to storage allocation problems. Okay, so we mentioned that we wanted to create a keyring. Now that we've pointed the queue manager at the keyring name that we want him to use, we now have to actually create that keyring. So we'll go into some JCL that I've pre-written and find a job that can accomplish the task of actually creating that keyring. In this PDS, the job that I have is called SSL create keyring. And just for general information, every job in the sequence that we'll be running today will begin with RTP as the job name, and then there'll be a character here. That character will either be A, B, C, D, E, F, or G, and the higher the letter or later in the alphabet the letter, the further along we've gotten. This job creates a keyring. It will create that keyring under the authority of MQM task, and it will add the ring with the name of secure.ring. And in this command here just lists out in our output whether there is anything associated with that keyring, as does this next command. So we'll go ahead and submit this job real quick, and we expect to get a return code 0. adding a character, and it completes. And we'll go to the command option here. And I've issued this command earlier, but I'll just grab it without typing it again all over. We'll just add it again. And we can see when we issue the rec dcert command, idmqm task list ring secure.ring, that it shows no certificates are connected to the ring yet. And that's as we expect. So our next step is to generate the root certificate. Let's go back to our JCL. And we have another job, SSL CRT CA, create certificate authority. This is job B. So under that same authority, we'll go ahead and generate a cert auth certificate. The common name for this certificate will be a root sir, and then we have additional distinguished name fields, but these fields are defaulting to nulls. The certificate will not be valid before May 28th, 2012, and it expires May 28th, 2022, so it's good for a period of 10 years. Has a key size of 1024. The bigger this key, the more secure the certificate is. There's the label, and the usage of this certificate will be cert signed, meaning it is a signing certificate, not a personal certificate. So we'll go ahead and submit the creation for this cert signed certificate. And the certificate also completes well. So we ran the job with job name RTB SSL. It created a root certificate with a common name of a root sir. The validity dates will make the certificate unusable if we're outside of that window once those dates expire, and you would receive a message in MQ if you did try to use a certificate which had expired. We'll issue a command on the commands panel again. Rack dcert, cert auth, list, label, and we'll give the a root sir label name. And you can now see our certificate does appear. It has the label we assigned. It has a system generated certificate ID. It has a status of trust. It does follow the time limits that we specified. It's been given a serial of zeros. The issuer is a root sir. This means that this root certificate has signed itself, so it is the bottom of our certificate chain, and every certificate chain has to be complete, ending with a certificate that has an issuer name and a subject name which are exactly the same. Once you reach this certificate in the chain, you've reached the end of the certificate chain, and if the chain is complete, then your certificate can be authenticated. This certificate has one purpose in life, and that's to sign other certificates. We are not using the hardware encryption available in ZOS called ICSF, so this key type is non-ICSF with a size of 1024, and this certificate right now is not associated with any keyring. So we've successfully created our certificate. Now we want to go ahead and connect the root certificate to the keyring. So let's back out of here and go to our trusty JCL again. And we'll find a job called CA, or Connect Certificate Authority. You can see here we're now on our third job, job C. We're going to be connecting the certificate to the keyring with this label indicating what the usage of it is, what keyring it is associated with, and then the job output, of course, would display any contents of that keyring. If we were to display that keyring again now, we would still show that there were no certificates associated with the keyring. So we'll submit this job as well and expect the completion code of 0. Job C, so I'll put a C just because. That's run. Now we'll go back, take a look on the command line. I'll paste in what was in the job and list that keyring we created earlier. And now you can see that the digital ring information for user MQM task now has its very first certificate in it, with a certificate owner of cert auth, usage of cert auth, and a default value of no. Okay, let's move ahead now, and moving a little bit off track, just cover exportation of certificates. We have another job here called SSL EXPCA, which is export the certificate authority. We'll just browse it. If you need to export a certificate to a data set, then you can run a job like this, and this, once again, job D is where we are. You'll notice that 2 exports are done here. We have an export of the same label. However, the format of each export is different. One format is cert Baker 64, binary 64, and the other format is cert dir. Now for this type of certificate, a signing certificate, I'll recommend that cert Baker 64 format be used. This root certificate is readable, which means that it will not contain a private key, and if it's later FTP'd, it ought to be transferred using the ASCII mode of FTP. The export with format cert dir is only included for the purposes of illustration, so you know that that's possible, and you would use that for a private certificate if need be. Notice that the data set that would FTP our root has a low level qualifier of ARM, and that's normally what I would expect myself to use if I was going to be moving a cert signed certificate into a data set on Z platform. So there are differences in the way the varying certificates are exported and moved to other platforms if you create them on Z. So let's go ahead and run this, and in a minute we'll take a look to see if our data set got created. We'll be looking for this .arm data set. Submit this job. This is job D, I think. And then we'll just take a look to see if a data set does exist, and of course it does. You can take a look at the attributes of it and see its variable block, LRUCL of 84 and block size, and it was created today, just referenced today. If you browse it, you can kind of see it does have some readable portions, begin certificate, end certificate, and this is a good indication that it's not a personal certificate. Now, you also should be aware that different certificates have varying extensions associated with them. One thing I did also want to mention was that when you list certificates out, when we listed the cert signed certificate, we did a RecD cert auth list label with the label name. For personal certificates, you would use this format instead, because this is meant to display certificates that are signing certificates.